Okay, so we have another problem here, and this one was sent to me by somebody who asked if I could help them. I said yes. So the problem, we have these two charges, one positive, one negative, the distance d apart, and they're on this line. Now, the question says if you imagine putting a positive test charge somewhere along this line, where could you put it to where the force is going to be 0? So let me go ahead and we're going to put a positive test charge somewhere along this line. Now, it could be on the left side, could be in the middle, or it could be to the right. Let's remember that test charges are always positive. Or at least we assume them to be positive. So let's think about what that means. Well, if I were to put a positive test charge on the left, that plus 4q charge is just going to repel it away. So we don't want to put it to the left. If I put it in the middle, the charge at point A is going to push it to the right, and the negative charge at B is going to move it to the right. So I also don't want to put it there. If I put it somewhere on the right, the plus 4q is going to try to push it away, while the minus q is going to try to attract it. Let me take care of sorry about that, I had the mailman come by. Okay, so to the right, the negative charge would attract the positive charge, so it would pull it to the left. But the plus 4q charge is going to push it to the right. So the charge has to be somewhere, let's say here. And I'm going to call the test charge q. The problem doesn't specify any amount charged, so I'm just going to call it little q. Okay. Now, let's say, I'm going to erase the... Hopefully that makes sense on why we know it would be on that side. And let's call the distance from B to Q x. Now, I don't know that distance, but we're just going to give it a variable. And what the question wants to know specifically is the point on the line. And we'll imagine that part A is your origin. So at A, you're at 0, 0. Okay? So the point on the line we're going to specify is going to be d plus x, essentially. So that's what we really need to find. Now let's draw a free body diagram for the test charge q. So that's what's next. What forces are acting on it? Well, the plus q is going to try to push it away. So this is the force A exerts on q. And B is going to try to attract it because they're opposite charges. So this is the force B on q. This is going to be helpful. We need our free body diagram to solve this. So that's our free body diagram. Now we know the force is given by Coulomb's law, which is K, the magnitude of charge 1, magnitude of charge 2, divided by r squared. So we're going to use that when we apply Newton's second law. So we need those. So let's do it. We want the sum of all forces to equal 0. Well, we have a positive, so K times the charge from A, which is 4Q, times the test charge, which I'm just going to call little q, divided by the distance between them squared. Well, the distance from 4Q to little q is d plus x. So that's going to be d plus x squared minus, now we have to do it for b, and that's going to be k times just q, little q, divided by the distance between them squared. Well, the distance from B to Q is just x, so it's just x squared. And we know that has to equal 0. So this is the equation we're going to work with. We can work through it a few different ways. I'll start by saying k times, these are positive, so 4k, big Q, little q, over, I'm going to keep it just d plus x all squared for now, is equal to k q little q over x squared. So I just added this over, and now I'm going to cross multiply. So what do I have? 4k big Q little q times x squared equals k big Q little q times, let's expand. So we have d squared plus 2dx plus x squared. Or 4k big Q little q x squared equals, we have k big Q little q times x squared plus 2k big Q little q times distance times x plus k big Q little q times the distance squared. Well, every term has a k in it, so we can get rid of the k. Every term has a big Q in it, so we could get rid of the big Q. Every term has a little q in it, so we can get rid of the little q. And what are we left with? 4x squared equals x squared plus 2 times d times x plus d squared. Right? Every term has a k, every has a big Q, little q. I think we did that right. Hopefully I didn't mess up here. Just cross multiplying, d squared plus 2 dx plus x squared. I think we did good. So we could subtract an x squared, and we'll get 3x squared equals 2 dx plus d squared. Or 3x squared minus 2dx minus d squared equals 0. Now, if I want to find the x value where that's true, I could use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, where this is my a. The 2 and the d are constants, that's my b. And then d squared is also just a constant. So even though it's a constant squared, we can just call it c. So minus b, so that's 2d, plus or minus the square root of 4 times d squared, minus 4 times a, that's 4 times 6, so that's, or 4 times 3, I'm sorry, so that's 12, times c, which is just d squared, all over 2a. Well, 2 times 3 is just 6. So we have 2 times d plus or minus the square root of, let's see, 4d minus 12d squared. That's going to be minus 8d squared all over 6. Did I drop a sign? I did. Minus d squared. This should be positive. I was about to say, I don't think so. Sorry about that. So minus 4ac, the reason it becomes positive is because you do 4 times a, which is negative 12, and then I just multiplied by d squared, but it's actually minus d squared. So the minus minus turns positive. That's my fault. So 2d plus or minus the square root of 16 times d squared over 6. Hey, this is looking really nice. So that's 2d plus or minus, the square root of 16 is 4, and the square root of d squared is just d, all over 6. So we have 2d plus 4d over 6 and 2d minus 4d over 6. Now I'm going to look at just this solution. I'm not going to look at the minus because it doesn't make sense if you remember at the beginning of the problem. This will give us a number less than d. So in other words, it's going to be somewhere over here. We don't want that. So x equals, let's see, that's 4d over 6, or x equals 2/3 d. Okay? And then if we remember, if we're defining, so that's how far we're going to be over here. But if we want to know how far we want to be from positive 4q, we would just do, so this is from the origin. I should specify that. This part's from origin. That's x plus d. But we know what x is. X is 2/3 d plus d. So let's see, that's 2d plus 3d all over 3, or 5/3 d. And this is how far you want to be from the 4q charge. Hopefully that makes sense, and why we did it that way. And let's see, we added that over. Pretty sure we did everything right. I went a little quick, but this is the general idea. We expand, we cancel all these terms, combine, quadratic. We got something really clean, which makes me very confident we are doing this right. We're not interested in the negative because that doesn't make sense. You would have minus 1/3 d. That would not make sense. That would imply you're somewhere in the middle. Yeah, that wouldn't make sense. You would be attracted to the plus q charge. Yeah. Yeah, I can't imagine a way, because that would be, I mean, in theory, you could be if the minus charge was bigger than the 4q, but the problem is it's going to be closer to the repellent force, and if B had a very, very large negative charge, it could get away with it, but I can't foresee any way where that would work. And on the right, I could, because the 4q is bigger than the minus q. So then we just said, I'm not specifically sure where he wants you to look at it from. This is the x value, so 2/3 d. But if you want it from the origin, you're going to have to add d to that. This x value is just telling us how far from B you are. But if you want to know this is d plus x. So hopefully that makes sense. I had some dogs barking, so I hope that wasn't too bad. And hopefully it helps you out.